I'm going to skip over the same things you probably heard 100 times a day, all the amazing opportunities with embedded vision and AI at the edge. I'm just going to instead start with the challenges of AI at the edge. So we're seeing this insatiable demand for DNN compute at the edge. And it's only getting bigger. It's only increasing. We're seeing a rapidly changing software ecosystem. So things that seemed like they were all the rage last year, like 3x3 convolutions, are now making way for new paradigms like depth-wise separable or dilated convolutions or lots of sparsity. So this is a really rapidly changing software ecosystem. We're seeing a demand for large models. Large models can absorb more data. They can handle edge cases better, but they also create a tremendous strain on compute resources. And to quote probably the most quotable guy in the semiconductor industry, Andy Feldman, the largest problems you see today should be the smallest problems that you think about. I think that's a great way to think about designing hardware. And finally, we're talking about the edge here. And when you push things to the edge, yeah, you get the advantages of reliability, latency, privacy. But now you're also in a world where you have really strict and tough power and cost constraints. But this is a massive opportunity that we're looking at here. It might be as high as $30 billion over the next 5 to 10 years. And anytime you have a new technology wave in the semiconductor industry, you get multiple billion-dollar companies created out of that who can think differently and leapfrog the incumbents and do things better, smarter, and faster.